To be able to understand how transformers work, we have to understand magnetism and magnetic fields. So let's have a look at this demo of a magnetic field. One way to prove a magnetic field exists is use one of these demonstration modules. So let's have a look what happens when I put a horseshoe magnet into this. So now you can see the magnetic field in 3D. The magnetic field is travelling from the North Pole up to the South Pole. Now let's have a look what happens to the field when I put a bar magnet through. So now you can see the magnetic field has moved these arrows and they're pointing, or the field is going from North Pole to the South Pole. When current flows through a conductor, it produces its own magnetic field. To show you how a conductor has its own magnetic field, let's have a look at this experiment with a power supply and a compass. The white part of the compass is facing north. Look what happens when we pass current from positive, which is on your right, to negative, which is on your left. The right-hand grip law states that if your thumb is in the direction of the current flow, the magnetic field wraps around the conductor that way. Let's have a look what happens when we reverse the polarity. We've reversed the polarity. Positive is on the left and negative is on the right. So the current flow is going left to right. So our thumb is pointing in the direction of the current and the magnetic field now is wrapping around the other direction. The conductor is looped to strengthen the magnetic field. If we put an iron core around these loops, it will further strengthen the magnetic field. Let's have a look at this experiment where we can turn a bolt into an electromagnet. So now we know the basic principles. Let's see the major components and how the transformer works. As you know, we need an AC supply. We have a primary windings, a secondary windings connected to the load. We can't use a DC power supply for a transformer because we need to change in the direction of current or the strength of the current. And DC doesn't give us that, it only gives us one direction. We use an AC supply for transformers because we need a change in direction of current and or the strength of the current in the primary windings to produce a voltage into the secondary windings, which produces a secondary current. Let's have a look at losses in a transformer. Some of the main losses is eddy currents. An eddy current is produced due to the alternating flux. An EMF is induced into the core, and that current in the core produces heat, and that heat produces an unwanted energy loss. The other loss in transformers is hysteresis. Hysteresis is a term to describe the lag between the change in value or the change in direction of a magnetic force and the resulting change in the magnetic flux. The change in magnetic flux causes a change in the alignment of the molecules in the magnetic material, causing heat. And that heat is a power loss or an energy loss in a transformer. So that's what hysteresis is. Other losses in transformers are the resistance in the coils on the primary and the secondary side due to their resistance. Also magnetic flux losses due to the air cores in the structure of the transformer. Not all of the magnetic field gets to the secondary side.